This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined today by Jim Connaughton, the CEO of Nautilus Data Technologies, and by Mike Completa of Elliott Bay Design Group to discuss the design and creation of barge-based water-cooled data centers. To start, Jim, can you provide a short overview of Nautilus Data Technologies, a by-the-number look at NDT today using the metrics of your choice?
Yeah, thanks, Greg. Real pleasure to be on with you, especially with our partners at Elliott Bay Design Group, and to be on with Mike, who put a lot of labor and love into this this first globally consequential project. Data centers are now new mission-critical essential infrastructure, just like power plants, just like shipping and ports, just like water treatment facilities. The electrons are important, the water is important, but now the photons of data is really, really important. And what we've done at Nautilus is we've married the best of maritime technology and adapted that for use in the data center environment to produce a data center that is among the highest performing in the world, the most energy efficient in the world, and critically importantly, super sustainable. Now, when you put those three things together, the fourth feature is flexibility and mobility, and similar to other forms of infrastructure like floating power plants or floating water treatment facilities or floating offshore housing facilities, we wanted to adapt that same thinking, that same large-scale modular thinking, to creating a floating data center. And so we have two elements to what we do. One is natural water cooling. So we take naturally cold water to cool the data center. I'll talk about that in a minute. And then we're showing that one approach to this would be to prefabricate it in the shipyard and deliver the entire data center to the shoreline and literally plug it in to power and to fiber and add new economic value, new high-skilled jobs into the maritime sector, but now plugging it into digital. And so this is intentionally about the intersection between the maritime world and the digital world. So that's conceptually what we're about. Now let me talk about the metrics. Most data centers today, believe it or not, are air conditioned. So think of a data center, it's like a Costco with 100 times the air conditioning. And as it turns out, that's just not a great way to cool rows and rows and rows of hot computer servers. And what we know from the maritime world is if you've got a hot ship engine, the best way to cool it is with naturally cold seawater. If you're running a petrochemical facility at the shoreline, the best way to cool that is to use cool water, natural water. It's how we cool our thermal power plants. It's how we cool our industrial processes. And so at Nautilus, we got our heads together with Elliott Bay and said, hey, let's figure out how we can create a floating data center and take advantage of the natural coldness of the water around it to cool that data center. And so instead of air conditioning it, we just threw moon pools in the bottom of the barge. We just gather up cool water. We circulate that through an open loop to a heat exchanger, very common in the maritime trade. And then we connect that to a closed loop of pure water inside the data halls where all the computers are. And we bring that cold water right to the back of the computer racks, just like you see on TV. And then we use that to pull the heat off the servers. Okay. And then we take that warm water back out to the open loop and put it back. Now, the beauty of this is it's very low temperature impact, lower than a power plant, lower than an industrial plant, lower than even a big container ship. Okay. So we are harmonious with the thermal signature of this industrial activity, which means we can do this without any concern about harm to biota, fish, and wildlife. So that's key to this. In addition, then we run quiet. So here's our metrics. We're 75% more energy efficient in our cooling compared to air conditioning. We consume no water. In order to air condition a data center, they actually plug into public drinking water, believe it or not. They retreat the water and evaporate it to create chilling. But we don't consume any water. We just borrow it for 16 seconds. Third, we don't use any water treatment chemicals because we don't have to create these big evaporative systems. We don't have to manage and maintain them. So no water treatment chemicals. And then we don't use any refrigerants. We get rid of refrigerants. And finally, no wastewater. Because we don't have an evaporative chilling system, we don't have the blowdown from that, we don't have to maintain any of that, and therefore we don't plug into wastewater. So basically we have a zero footprint system that's super efficient, and then wonderfully it runs quiet. What you see behind me is the work product, the first version of this. That's a 7 megawatt data center sitting on a 240-foot barge vessel, fully encased, 3/8 inch thick steel, runs quiet. If you walk by it, you wouldn't know it was on. And that's providing, key data services right into the heart of Silicon Valley. So that's what we can do. Now, finally, a key metric is, in addition to everything I described, we want to build in the maritime environment. So ports are our friends. We can bring new economic activity and vitality to the ports. We can be the anchor for the cable landing stations that typically come through the ports all around the world. And then we can add, intersect with smart maritime, smart transportation, smart city, smart grid. You hear about smartness. Well, to make smartness smart, you need data centers. And the best place to get those data centers right into the heart of our population centers is to partner with the ports and the other shoreside industrial players.
I understand that NDT technology was validated recently with the launch of Project Nautilus, reported to be the world first in waterborne data center operations. Can you discuss the project, its partners, its cost, and details of the shipbuilder and its status today?
Yeah, so in order to do what we do, we depend on great partners. It starts with the design, and our best partner in this process has been the Elliott Bay Design Group, who've been with us since day one. We are quite ambitious to start. We're a startup, and so we decided we were going to refurbish an existing barge. And so a lot of thought had to go into taking an existing platform and converting it and reimagining it in order to support this infrastructure. It was quite challenging, but at the end of the day, it was the most environmentally sustainable thing we could do to actually recycle a hull. Okay, and so that's like the high watermark in the best sense of the word. And so we recycled, refurbished the hull, put our mechanical systems below, and then all the data center and electrical systems are above the deck. And it was a deck barge. Our other key partner was Linde Marine, the shipyard in Vallejo. It's the old naval the naval station in Vallejo, the Mare Island Naval Station, which is one of the most important submarine stations in the world for the U.S. Navy, since abandoned by the government and now being revitalized. So we were part of the revitalization of Mare Island and partnered with Linde Marine. They have a big old dry dock there that we were the cause of them reopening the dry dock. That was very exciting. I think it hadn't been opened in more than 20 years until we came along. So that was kind of fun. And then our other great maritime partner was the Port of Stockton, who very early on said, "Hey, this is a really exciting project for us. We have a lot of spare real estate, and we want to go digital. We want to go green. And what's nice about what we do, if you look at the picture behind me, is we don't even need a finished berth, right? As long as we've got a good, stable riprap shoreline and the sufficient water depth of about 5 meters, we can just float the data center right in. We take some technology from the liquefied natural gas sector in terms of the pilings that we use to moor the vessel. So they're on a sliding piling system. And then some very, relatively straightforward shoreside electrical and mechanical infrastructure to make this all work. And then on the shore side, we've built a beautiful new warehouse and office and security center. And then we have a utility pad. And this corner of the port, which was once the most blighted corner of the port, is now the most beautiful location on the port.
So Jim, today, how many data center barges are either in operation or under construction?
So this facility is the first one. It was commissioned right before Christmas during COVID. We ran a COVID-safe work site, by the way. We came in ultimately, on time and on budget, which is key. After a lot of the innovation work had gone by, and then there's a process of then running the facility and burning it in, if you will, of about 90 days, and we've just started to market it. So this is the first facility of its kind. We started the marketing of it in April, May. And we're now onboarding the first customers. We are in design work with Elliott Bay right now to take all of this sort of custom work that we did and now turn it into a classic modular construction and deployment capability. So we are intensively in the design work right now for future projects in Limerick, Ireland, at the port of Shannon Foynes. Again, another great port partner. We're hoping to partner with the port in New South Wales in Australia. We're talking to a port partner in Marseille, France. We're talking to a port partner in Africa. So each time we're looking for locations, we keep coming back to ports as a partner. So we are looking forward to, in the next 2 to 3 years, I hope we'll get at least 10 more of these built. And then for folks that want to partner with us, so if there's local developers that want to do data centers and go for a water-cooled option with the option of having it floating as well, we hope to actually have even more projects going that we're not building, but that we're supporting and supplying services to others.
So, Mike, from the naval architecture side of the story, what is unique about the NDT barge versus standard barges? Can you specifically discuss the unique design and equipment aspects?
Absolutely, Greg. That's a great question. And Jim's done a fantastic job of giving a great overview of the barge, how it works. So make my job easy to give a little bit more insight on this. From a naval architecture side, I would say in one respect, really nothing's different about this barge from most of the barges that are out there. And that's actually, I think, a really cool thing because, we see a lot of facilities that are built to connect to the shore. They're built as a steel platform with, a traditional like skin and pole building, more of a land-based building on top. They're really set to be built in position. This is built, the superstructure that you saw in Jim's background is built to full marine standards, ocean marine standards. So that barge can be pulled anywhere on the planet and, really stand up to the ocean environment. And as Jim explained, going to the different, potential for moving this to different countries or different places in the world, the centers themselves, building these in other areas, who knows where the new centers will be built versus where they'll be installed. So we wanted to really create a product that could be mobilized and remobilized really anywhere in the world. One thing that is, I think, the structure and the hull form side are not particularly unique. The systems themselves are very unique in this vessel. Jim went into quite a bit of detail about how the cooling system works. One item that he didn't touch on is how the cooling system's oriented. In most barges and ships, you have a sea chest, at the aft end of the vessel, kind of down low, where you take in the water and then discharge back out kind of in that same area or back out the stern. In this case, because we're facing upstream in a current, we're taking advantage of that natural flow of the current. The water comes into the intakes at the very front of the barge and then runs through the vessel, through the piping system in the vessel, and then back out the back end of the vessel. All of the primary systems that serve the data storage are also fully redundant, even to the point where certainly the raw water intakes, there's a duplicate system. Each side of the system can serve the vessel in its entirety. Also, the electrical system is pretty unique on this as well. A lot of vessels have redundant electrical systems, but Nautilus has gone so far as to actually separate the shore power into a 50-50 split at the forward end and the aft end of the vessel for redundancy. So basically, if one whole side of the server system goes down, they still have that backup power, that backup storage for serving their customers. So on the system side, yes, absolutely, probably one of the most unique vessels I've ever worked on.
You've already discussed it a bit, but much is made of the water cooling system on these data centers. Can you take a deep dive on the water cooling technology and system specified with insights on redundancy to ensure continuous operations?
Absolutely. So as I mentioned earlier, the seawater side is fully redundant. Unlike most vessels, the seawater cooling lines are much bigger than typical vessels in this. We've got 18-inch cooling lines. That's done intentionally with some other features on the vessel that I'll talk about in just a second to really minimize the environmental impact, and especially to the fish and the sea life in the area. There are large rotating screens on the end of the vessel where the water comes in, and with the big diameter cooling lines with the natural convection of the river, the flow through the system is very light. So any fish that do get into the vicinity, the intakes are able to swim away. They're not going to get sucked into that screen and held against there until they die. The screen is also a very fine mesh, and it has a system that it continually moves to keep it clean and clear of any debris. Because that mesh is fine, it has to be kept clear. But again, that keeps any fish from being pulled into the system. once that water gets into the system, there is an ultraviolet light treatment that does keep any barnacle and mussel growth from occurring inside the system itself. From that point, it's pretty much a traditional, seawater heat exchanger side of things.
I see that there is a closed loop and an open loop water cooling system. What are the pros and cons of both, and what are the drivers to select open or closed?
Great question. I think it's very similar to when you're operating an engine on a ship or other systems on a vessel. You want to keep the seawater away from the mechanical components, away from the really mission critical system. So by taking in that seawater through the open piece of the system and then using a heat exchanger process to keep a closed loop serving with treated cooling water serving the racks. Also, inevitably there's going to be some impurities that get in from the seawater side of things into the system, so you don't want that going through the finer tubes and other elements of the racks. And again, if there's any leaks or anything like that in a closed loop system, the most that can leak out of the closed loop is the fluid that's contained within that. If there's a leak in the raw water side, obviously water will keep pumping into the vessel forever. So that also protects the technology, the servers, and everything else in there from any kind of massive damage.
Jim, having covered the maritime industry for nearly 30 years, I certainly understand barges, data centers, not so much. What are the chief advantages to building and operating a data center on the water versus a land-based facility?
Yeah, so the core advantage to what we do is the natural water cooling compared to chilled air systems. And then the floating version of this provides some additional flexibility advantages. So what's important really from a maritime sector perspective is that we can be floating beside the land, or it can be on the land beside the water, but they're both sort of in the maritime orbit, which is familiar to everyone watching this program. And so the advantage of the vessel is the ability to, to prefabricate the whole thing in a controlled environment, pre-test it, pre-commission it, okay? So you can get a lot of great work done by skilled workers in the environment in which they're used to working, right, in shipyards, okay? So you don't have to create the added risk of building something stick-built or from scratch, at your end location. That's very important for quality control and very important for the sort of integrity and resiliency of this mission critical environment we're creating. Now, the other advantage is in the developed world, as the Panamax ports get bigger, the mid-sized ports have capacity now, all right? And so we can restore economic opportunity, new, especially digital opportunity to these ports, while allowing them to sustain their operations and maintain the maritime character of what they need to do. And then, as I mentioned, in the developing world, this is the floating and shoreside capability we have allows us to go where these countries already have, a core of their economic resiliency is at their ports, right? And at their industrial facilities at the shoreline. And so we can add more economic activity. We can take advantage of the power connections. We can take advantage of the highway and rail connections. And again, create a more of an integrated mission critical space that will allow the developing countries to catch up with us.
Now, we've obviously discussed many of the pros for the system, but in my experience, where there are pros, there are always cons. When you look at your system versus the traditional systems, what are some of the drawbacks and/or what are some of the chief maintenance items or concerns with a waterborne facility versus land-based?
Yeah, the nice thing is about our approach is we took a white piece of paper, working with our partners at Elliott Bay and some of our other partners at Lynn Marine and some of the other folks. We took a white piece of paper to say, how do we eliminate as many problems from data center design, build, operation, and management as possible? So when you ask about the cons, our business model was to eliminate the cons. Okay, so what we have is this near zero impact facility. The only con of which really is it's in a new geography. Putting it into a port or an industrial shoreside environment is new to the sector. So the sector is used to sitting in the commercial real estate side of town, expensive real estate. The data centers are noisy, okay? And they're taking up a lot of land that could be put to valuable uses with people, rather than with machines. And so from the data center perspective, we have to educate our peers that being on the port side of town is the better place to be. Secondly, we are circulating a lot of water. Okay. Now, data centers themselves use a lot of water and refrigerants and chemicals to do their chilling, but they're not used to having a circulating water loop inside the data hall. Now, we solved for that using maritime technology that you can find in our naval vessels, our carriers and our submarines, because we pull the water through under negative pressure. Okay, very similar to what you would see in these military vessels. And we pull it through under negative pressure and then are able to create a leak-proof environment, okay, with a pure water loop inside the vessel. Now, as we all know from the maritime sector, these are highly durable systems. I mean, and we're using pure water, so we don't have any corrosivity or chemicals or other things. But as an added layer of assurance for our customers, we can show them how this closed loop operates under about half a bar of negative pressure, which means if something happened, like a hose popped or a valve was open, or maybe maybe we got the torquing wrong on one of the flanges, air gets sucked in instead of water coming out. And then, as Mike described, the entire system is redundant. So alarms go off, air sucks in, we capture the air, we flip to the other system, and then we pinpoint the problem. Now, we've been running for 8 months, and that we've had no problems, as expected, as designed. Elliott Bay did great work, but it's an extra layer of insurance, and that's new to the sector as well.
If a potential customer watching this is interested in sourcing an NDT waterborne data center, what's the process? How long does it take from contract signing to operation?
Thanks for that question. So there's two categories of folks we really want to talk to, which is one, of course, customers. And this first data center, 7 megawatts, it's right in the greater Silicon Valley area. This is prime location, super sustainable, and as indicated, high performing. We can support the most powerful new machines in a way that the existing infrastructure can't. And then our typical project will take 12 to 18 months to stand up, which is about twice as fast as you might otherwise see, because it's super modular. Now, if you're a partner, so if you're a port, if you have real estate near the water, near these urban centers, you're a local developer, right? We are completely ready to have a conversation about how we could support your own development of either a floating data center or a land-based data center at the shoreline, one or the other. So we're very well positioned starting really in about December, when we have our final, we're working with Elliott Bay and our design team and our architecture team on these big modular packages. So those will be ready to go. We'll know what the pricing is on those. We'll know what the services is around all of that. So starting at the end of this year, anybody looking for the option of water cooled, that'll be available to them. So we'll build in our own, but we'll support others building, because our objective is to get the whole sector to switch to water cooling. So we'll build on our own and we'll license out to partners.